Okay, so now I want to look at another example here of one of the problems from your textbook. Now, again, I like to scaffold my learning, so we start with something simpler and then we get something a little bit more complicated. So what you're going to see here in the textbook under this Coulomb's law, first they have problems sort of in the sections. They don't have it at the end of the chapter. They have them as they go in. So they go through here, and this is one of their problems that they've got here. And we're just going to talk about it conceptually first. And then I'll eventually give this one to you as a problem that you can work through. But when you start thinking about this, this is conceptually easier than it seems at first. Okay? So it talks about 12 equal charges are situated at the corners of a regular 12-sided polygon. For example, one on each numeral of a clock face. So I'm going to come over here real quick and do a quick Google image search so that you guys do not have to deal with me. And I will use this one, I think. Well, no, I want to just we'll grab this one. I like this one because it's got the degrees on there. Oh, no, that's not the degrees, that's the minutes. But we could easily transcribe that into actually looking at the angles, okay? So we could think about this if we look at our standard polar coordinates. I'm just going to write these in here. This is at 0 degrees. This would be at 90 degrees. So this would be 30. That would be 60. This would be 120, etc. We could go through and we could find these positions. And so if I look at this, I've got a distance, so my R magnitude here is actually the radius of the clock, and so that's going to be some static value I'm going to call capital R, and maybe that's 1 meter. And for each one of these, this is my big Q, and these are my little q's as I go around. They're at different angles. You could find these in terms of an XYZ coordinate, because if I look at Q1, well, it's going to have an X value, which is going to be R cosine 60 degrees. And then it's going to have an R sine of 60 degrees. And that's my I hat part, and that's my J hat part, and this is actually 0 for the K hat part. I can use trig to put these in vector notation. Now that's not Q1, that's the R1 prime, okay? And my, not cursive R, that's going to be my R prime. My R is my field point, that's at the center. I could use that R and R prime to calculate the force vector due to charge 1. And then I would have vector force, and I don't know off the top of my head what the number is going to be, but I know that if those are both positive charges, it's going to sort of repel, and so that's going to be somewhere in the negative I hat direction and the negative j hat direction, and 0 for k. Because it's going to be pushed away, and so it's going to be somewhere in that direction.
So you said minus or plus for I hat?
No, sorry. Let me rewrite this more carefully. For charge 1, it would be a negative number, I hat, a negative number, j hat, and 0, k hat. Now, hopefully you can see that I don't have to go through and do all of this and plug it into the formula, because I know the magnitude of the separation and I know the direction, the angle. I could go through here and immediately write out that my force is going to be the 1 over 4 pi epsilon naught. My value for little q, my value for big Q, my radius cubed, cosine 60 plus sine 60. That's on Q1. But I've got another charge over here. This one is going to repel in that direction. And they're the same distance away from each other. And so I'm going to have exactly the same, but it's going to be exactly the opposite direction.
Well, at 8, at
Yep.
one charge, that's 60 degrees.
So the charge 8 is going to be at, let's see, that would be at 210 degrees.
I agree. But we use cosine 60.
So we had cosine.
Oh, okay.
Oh, because sorry. Hold on just a second. You are right. I am doing things in the wrong places because I had talked about Q1 being at 60 degrees, and so this is the force for Q1, and then the opposite of that would be 7. And so the force due to Q7 is exactly opposite. Q2 and Q8 would be opposite of each other. I'm not very good at drawing straight lines here.
Q7.
Okay. Hold on. Let me do this using full arrows. Okay? For charge 1, I go from the position 1 to here, and that defines my R vector. For Q7, it would go from this point to that point. Then Q2 and Q8 are exactly opposite of each other. And Q3 and Q9 are exactly opposite of each other. So for this problem, there's a simplification. I need to not be on the arrow there. Where Q1 and Q7 are equal and opposite. That's 7, not 2. And Q2 and Q8 are equal and opposite. All the way around. And this is true because all Q's were equal in our problem, and all of my separation distances are equal in this problem. So my net force at the end is going to be what? Each pair is equal and opposite. So what's going to happen when I add up all 12? So it initially sounds like this is a horrible problem. But it's not, because you don't have to actually calculate your numbers for all of them. Okay? If they were not all equal charges and not all at the same distances, then you would have to do it all. But as we'll see, we'll make the computer do that for us. Okay? Now, the second part of this problem we'll talk about a little later. Let's say you took one of those Q's out, like the number 6 one. Well, the other pairs are all still going to balance, so we only have to find the force from Q12. And we don't even have to worry about the trig in that, because we can look at that and say that's going to be along the y-axis. We would know what we've got. Okay? So there are often shortcuts. Rather than having to do all the math with a number, when we get to this level, you can do simplifications. So that's what we're looking at in this problem. And so for part B, you'd really only have to find the force on our big Q due to the Q at the 12 position. Not all of them. Okay?
Big Q is the middle dot.
Big Q was that middle one right here. That's my test charge, my field point, due to all these fixed source charges. Okay? So when they come up here and they ask you, what's the net force on the test charge, big Q at the center? Take advantage of symmetry whenever you can. Okay, so I'm going to stop this video.